Hello students, in today's session we are going to learn how to implement linear regression model by taking example build a machine learning model to predict the price of a car based on its mileage and age using scikit-learn. For this example we need to use linear regression model because here we want to predict a continuous value. As car price is based on its mileage and age, we can say the data here is linear data. So always in such cases we need to use linear regression model. Then what are the steps that we need to follow for implementing linear regression model? First of all, we need data set. This data set we can directly read from CSV file, or we can create data frame in program itself also. So what features we need for this data set? As given in the problem statement, we will need mileage of the car, age of the car and price of the car. After taking data set, next task is splitting of data set. So some data will be used for training and some data will be used for testing. So train test split is an inbuilt function that is used for the splitting. By default 80% data is used for training and 20% data is used for testing. We can change this proportion as per our requirement. After splitting of data, next we need to train the model. So here linear regression is inbuilt function that we can use, and then fit method is used for actual training the model. So this train data which we have splitted, that is used for this training. After training the model, next task is to check what values it is predicting. So here we can use the test data set for checking the predictions, and then we can check performance of a complete model, and also we can plot different types of graphs. So all these things we will see in the program. So yes, at first we need to import some modules that are needed, like numpy we need, pandas we need for data frames, then matplotlib also we need for plotting purpose. Then from sklearn we need different methods. Then we start with creating a data set. Now here I will tell you both the ways how data set can be created in program itself, that is data frame, or how we can read data set from CSV file. So initially we have created this data where we have mileage. These are some values for mileage, then age. So total 10 rows we can say present here, and also the price is given. Okay, then we are implementing linear regression based on this data. Then yes, as I told you, first of all we need to convert this data into data frame. So for that purpose df is equal to pd.dataframe we need to perform. After completion of this step, we will check what it is showing us in the df. So I'll make it comment, then we can check data set. So now I'm printing df. So yes, here you can see this is our data set. Total 10 rows are there. The mileage, its age and its price. Mileage, age and its price, and so on. So total 10 rows we have. Then next, now we will define a given data set in two categories. First, we will have X which shows us the feature, and we will have Y as a target, or we can say it is dependent and independent data or feature. So here if you see, price is a dependent variable, so we are just creating two different data frames. X is a data frame which is consisting of mileage and age, and Y is a data frame which is consisting of price. Then after creation of these two variable x and y, next we will split data into train and test set. So its format is like this, syntax is like this. Yes, obviously we need two variable. So x underscore train, x underscore test. It means that whatever x data frame we have, mileage and age, total 10 rows we are having in data set. From that 10 rows, some data will be used for training. So whatever values in the x, so x train and X test. Total X frame is divided into these two parts. Same way, whatever data present in this Y variable, data frame present in Y variable, we will distribute it in Y train and Y test is equal to train test split in bracket X comma Y. So directly we are providing this X and Y as an input for splitting. Then we will get X train, X test, Y train and Y test. We can check by displaying it. So I will display print X underscore train. Also I'll print X underscore test. Now whatever complete data set we have, I will find that it is now divided into two parts. So see here from this part. So this much data set is used for training. Row number 8096354. So randomly it is taking the rows, and the 7, 2 and 1, these numbers of data is used for testing. So basically, as our X is consisting of only mileage and age, this is the distribution. X test and X train. Similarly, we can also print Y test and Y. Print test, Y test. So see what it will show. Again same. Here also, if you see, this data is used for from this, yes, 754160. This data is from Y, because Y is consisting of only price. So this data is used for training, and 893, this data is used for testing. So if you see, so from X also the same rows are used for training, and from Y also same rows are used for training. Okay, so in this way we can split data set. After splitting, now next task is training the linear regression model. So as I told you, linear regression is inbuilt function that we can use directly like this. And what data we need to provide for fit function? X train and Y train. Because as I told you, this train, X train and Y train, this data is used for training the data set, training the model. And then after training the model, we need to check its predictions. So for prediction, obviously X test data is used. So here we can check it by printing this Y prediction values. So let's see what it is showing. So basically in X test, what data we have? If you see here, in X data set, in X test, sorry, we have these three rows, 8, 9 and 3. So its mileage is this, age is this, and its respective price is this, 5,000, 4,000 and 14,000. Now we will see what the model is predicting. Okay, see here model is predicting these values. So as you can see, these values are displayed in the list format. So first value is 6,420. So this prediction is for this first row. So actually the price of the car is 7,000, but here it is predicted by the model is 6,420. Then same For the second, this is the predicted value, and for third test data, this is the predicted value, and this one is the actual value. 16,000 was the actual value, actual price of the car, but here in prediction it is 15,978. So in this way our model can predict the values. Now we will use this R2 score function for checking its performance. So syntax is like this: R2 underscore score, and yes, what we want to check? We want to check Y test values with Y prediction values. Y test values are given in the database, and Y predict values are predicted by the model. So we will compare these two, and then we will check the accuracy of the model. So I execute it. So if you see here, R2 score is 0.99. So we can consider like 99% accuracy we have achieved by implementing this model. Again, this accuracy is completely depending on the data set which we have. So in this case, for this data frame which we have created in the program, the accuracy is like 99%, we can say. It is near to 1, 0.99. That means we got the maximum accuracy. Now after prediction, after checking accuracy, now next we will visualize this data. We will plot a scatter plot where we will mark Y test and Y prediction values, so that we will get its representation in graph. So yes, this is the graph. So this y-axis is showing predicted price, x-axis is showing actual price. These dots are nothing but the predicted versus actual car price. So in this way we can implement linear regression, we can check its accuracy, and we can also plot the predicted values and the actual values. So here one more important thing is there, whenever we have a data set, so after taking the data set, the first important thing, we need to pre-process it. We need to check whether the data is correct, whether the data any impurities are there that we need to remove. Okay, so in this program we have taken data frame in program itself. As I told you, there is one more method. We can directly take data set from CSV file, so we will do that one also. So I have downloaded a data set whose name is car underscore data.csv. Now wherever our program file is saved, at that same location this data file need to be present. So car underscore data.csv is the file, so that directly we can read by using this pd.readcsv, in bracket we can give its name, and in such case there is no need to have this conversion of the data frame. So I'll make this line comment. We'll execute it. Let's see what happens. Just okay. So this is the data set that we have taken from the CSV file. This is complete data set. Then these are the values of X train. These 3 rows are for X test. Then these 1, 2, 3, 4, 5, 6, 7. These 7 rows are for Y train, and these 3 rows are for Y test. And then we are trying to display this predicted values. So if you see, for this first Y test, the value was 4 lakhs and the predicted value is 4,20,843, which is nearest to this predicted actual value. For row number 8, the actual price is 4,60,000 and the predicted price is 4,74,127. For this row number 3, the actual price is 3,70,000 and the predicted price is 3,61,000. Okay, and yes, if you check accuracy is 0.83. So we can say 83% accuracy we have achieved by this data set. So as data set is changing, the accuracy is also changing. And yes, this is the plotting of actual versus predicted car price. So this is the example how we can upload CSV files, how we can create data frames, how we can train a model by using linear regression model. Thank you.